Meteorites that strike Earth don't necessarily come from the deepest parts of the solar system, sometimes even from our nearest neighbor planet. In fact, over the years, researchers have retrieved hundreds of rocks of Martian origin. When a powerful impact strikes Mars, pieces of the Martian surface can be hurled into space with enough force to escape the planet's gravity. Some of these pieces enter orbit around the Sun and eventually cross Earth's orbit, falling as meteorites. Such Martian visitors are rare but not unprecedented, and scientists have confirmed at least 10 such meteorite-forming events in Mars' recent history. Scientists from the University of Alberta have now traced the origins of 200 of these meteorites to 5 impact craters into volcanic regions of Mars known as Tharsis and Elysium. We can now group these meteorites based on their common history and further group them based on their location on the surface before they reached Earth. In a study published in the journal Science Advances on August 16, the University of Alberta team calculated that about half of the 10 Martian meteorite subgroups known on Earth came from specific regions of Mars. The results are based on an improved model of Mars physics, which is key to understanding the ejection process after an asteroid impact. The researchers combined this improved understanding of ejection dynamics with remote sensing data detailing the geological composition of Mars to narrow down the meteorite's origin. The team combined high-resolution simulations of impacts on a planet like Mars. One of the biggest advances here is being able to model the ejection process and from there determine the size of a particular meteorite group, and even the size of the crater or range of crater sizes that may have ultimately ejected a particular meteorite. Meteorites fall to Earth every day, and NASA estimates that about 44,000 kilograms of meteorite material reaches Earth every day. But Martian meteorites are particularly valuable because they provide a direct link to Mars' past. In the 1980s, volcanic Martian meteorites were identified that were roughly 1.3 billion years old. These results suggested that there was recent volcanic activity on Mars, and were confirmed when NASA's Viking landers matched the gas composition of the meteorites with the Martian atmosphere. Now, experts believe that about 200 of these meteorites have been assigned to 5 specific impact craters into volcanic regions on Mars. The researchers now believe that 5 of these craters, located across 2 volcanic regions called Tharsis and Elysium, are likely the source of the roughly 200 meteorites described in the study. Upon further analysis, the researchers believe that these samples will likely help provide a better understanding of Mars' geological history,